Hi guys, in this video we'll be looking at the series circuit and what you need to know on how to approach. Now the reason we call this a series circuit is because of the way the resistors is connected to each other and because there is only one path for current flow in the circuit. Now in this circuit, the first thing that you want to do is to find the total resistance of the circuit. In the series circuit, it will simply be R1 plus R2 plus R3, which means you will just add the resistances together because it is a series circuit. So my total resistance will simply be R total is equals to R1 plus R2 plus R3, which will give me a total resistance for the circuit of 12 ohm. The next thing that we will be calculating is calculate what is the total current flowing in the circuit. And this I will do by making use of one of my Ohm's law formulas, which says that my total current is equals to my total voltage of the circuit divided by my total resistance, which I've already calculated, which will give me 15 divided by 12, and I have a total current flowing in the circuit 1.25 amps. Next, I will be calculating what is the voltage drops over each one of my resistors. So my voltage drop V1 over resistor R1 is going to be my I total times R1, which is 1.25 multiplied by 2, which will give me 2.5 volt, which is the voltage drop over resistor R1. The reason why I use I total in the circuit is because, as I've said in the beginning, this is the only current that is flowing in the circuit because we're working with a series circuit. The next voltage that I'm going to calculate is my voltage drop over resistor R2. And that will be voltage V2 is equals to I total times R2, which is 1.25 times 4, which will give me a voltage drop of 5 volt over that resistor. And V3 will be my I total multiplied by R3, which is going to be 1.25 multiplied by 6, which will give me a voltage of 7.5 volt over resistor R3. Now guys, in these circuits, there are two laws that we need to understand. The first one is Kirchhoff's current law, and the second one is Kirchhoff's voltage law. Now, when we talk about series circuits like this, we will use Kirchhoff's voltage law. And the reason for that is because we're working with a series circuit. And Kirchhoff's voltage law states that the sum of the voltage drops will be equal to the total voltage in my circuit. And that's why I want to show you, if for instance we have calculated V2 like we calculated there, and V1, we can now make use of Kirchhoff's voltage law to calculate V3 as well. So I'm going to use Kirchhoff's voltage law, and we're also going to calculate what is the voltage V3 over my resistor R3. And that will be that V total is equals to V1 plus V2 plus V3, which is Kirchhoff's voltage law. And because we want to calculate V3 here, we need to say that V3 is going to be the subject of my formula, which is equals to V total minus the sum of the two voltages, which is V1 plus V2, which will be 15 minus 2.5 plus 5, which will then give me a voltage drop of 7.5 volt, which is then also the voltage drop over my third resistor. Next, we will calculate what is the power absorbed in each of these resistors. So the power used by my first resistor, my formula will look like this. PR1 is equals to my I total multiplied by V1, which will give me a total power absorbed by the resistor of 3.125 watt. So the power used by my second resistor will simply be my current, which is 1.25 multiplied by 5, which is the voltage drop over that resistor, and I will have a power of 6.25. So the power used by my third resistor will be 1.25 multiplied by 7.5, which will give me a wattage of 9.37 watt, which is the power used by the third resistor. So the total power of the circuit will be power R1, 2, 3, added together, and I will get a total of 18.75 watts for the whole circuit. Now guys, what you can do is, if you have calculated all of that, now you can use the same power formula, but now you will take everything in total. Remember, the only current that we have is I total in the circuit, so I need to use that. And then I'm going to use my total voltage in the circuit. So we need to get the same value. And as you can see here, 1.25, which is my total current, multiplied by my voltage, which is the total voltage of the circuit, is also going to give me 18.75 watt, which means we have actually worked correct. Now guys, what I didn't show you is we actually have three power formulas. That is the first one that I've used. Then we have a second one, which is this one. And we also have a third one. Now, provided that you have all of the variables in the sense of the current, the resistance, and the voltage, you can use any one of these power formulas. You will get the same result in the sense of, if I have the current and the resistance of resistor R1, I am still going to get the same watts, which is the same power for that specific resistor. Same for this one. If I used the third power formula and I have the voltage and the resistance of that specific resistor, I'm going to get the same power for that if I use the third power formula as well. So guys, I've come to the end of the video. Thanks for watching. I hope you enjoyed the video, and subscribe to my channel, hit the notification bell so that you can be notified when I upload a new video. Thanks for watching.